Here we go, 5 quadratic formula. So we've learned several methods before. We've graphed, we factored, we used square roots, completed the square, which is kind of crappy. I don't use it a whole lot. But another method is quadratic formula. This formula, it's long, but it's powerful. It can solve anything. Some question you have really no other option besides using this. So I'm going to kind of show you what I'm talking about. So first example is, first thing I always try to do when I try to solve an equation, and I want to find the zeros, meaning I want to find out when that's going to be 0, I try to factor it. So I try to figure out if there's two numbers that can multiply to make 10, but can add together to make -8. It can't really happen. So if I try this, I think about the ways to multiply to get 10. I got 1 and 10, 2 and 5. There's really no way to get a -8 out of that. So that's when I got to bail. And I'm like, crap, I got to use quadratic formula. So here's what it is. Standard form is ax squared plus bx plus c. So the a, b, and c represents the coefficients in front of those letters. And then we got this big nasty formula up here. So this is what we're going to be plugging and chugging with. One thing I do want to make you aware of is this piece underneath the radical, that b squared minus 4ac, that's called the discriminant. It's going to be important later on. So if you ever hear me talk about the discriminant, I'm talking about that part. And that little piece allows me to analyze an equation early and know how many zeros it's going to have and whether they're going to be real or imaginary. All right, let's get after the mechanics. So first of all, a, b, and c. A is 1, b is -8, and c is 10. So I pulled those from right here, these coefficients. Now I got to jam it in the formula. So -b, which is like opposite b. So I have opposite -8 plus or minus square root of. I wouldn't do this in the calculator just yet. I'd do everything I could in my head first. So b squared is -8 squared, which is 64. Take away 4 times a times c all over this 2 times a. So 2 times 1 is just 2. All right, so let's tighten this up a little bit. I got 8 plus or minus radical. That's 64. Take away 40, which is going to be 24. Got a little carried away with that radical there. And now what I need to do, this is kind of like a little side project. I got to try to simplify this radical. So we did this in like chapter 1 in this course. You've probably done it in other courses. But I'm going to go off to the side and do a little bit of scratch work. So to simplify that radical, I'm going to use a factor tree. Pick any two numbers that make 24. I'm going to go 3 and 8. Break it down until it can't be broken down any further. So 2 and 4, 2 and 2. Once I got it broken down, you count up your pairs. A pair counts once. Put it on the outside. If there are any other pairs, you keep putting them on the outside. I got 2 loners left, a 3 and a 2. Loners stay inside. They don't go out much. So that would simplify to 2 radical 6. So what I'm going to do is I'm going to replace that square root of 24 with a 2 radical 6. Since I'm running tight on room, I'm just going to erase this. Slap a 2 radical 6 in there. All right. That looks a little bit weird, so it bugs me. So now what I got to do, I have 2 numbers on top, a fraction on bottom. I'm allowed to split this up into 2 separate pieces. So let's divide both chunks by that 2 and simplify. 8 divided by 2 is 4, plus or minus. These 2's cancel. So the exact answer to this problem, the 2 zeros, are 4 plus radical 6, 4 minus radical 6. If you need an approximate answer, you go 4 plus radical 6. Put that in your calculator. 4 take away radical 6. I can't do this in my head, so I'm going to have to cheat real quick. Second quit. 4 plus square root 6. Do it. About 6.45 would be 1 0. And then 4 take away radical 6 is 1.55. We'll call it about 1.6. So these are the 2 approximate zeros. This is the real deal pickle. That's the exact value. All right, it's pretty straightforward. Long, but straightforward. Less talking, more working on this next one. So here we go. First thing, knock out A, knock out B, knock out C, stick it in the formula, opposite of B, plus or minus the square root, B squared, negative 1 times itself, take away 4 times A times C, and all divided by 2 times 2, because remember it's 2A on the bottom, so I got a 4 there. Tighten that up, bam, 1 minus, what's that, 16, so we got negative 15, all over 4. And here's where all hell breaks loose, because your calculator is like, wait a minute, we can't do the square root of a negative number. You know, if you try to stick this in the calculator, you're going to get an error. So mathematicians said, well, we got to keep going. So what we're going to do is we're going to invent some imaginary numbers. So what they did was, they said, hey, we know that the square root of negative 15 can be rewritten and times the square root of positive 15 times the square root of negative 1. Like you're allowed to do that with any radical. You can break it up and multiply it by 2 factors. And then they said, since we don't know what the square root of negative 1 is, we're just going to call this thing right here, we're just going to call it I. And that's going to be how we define an imaginary number. An imaginary number is just the square root of negative 1. So it kind of created a fix. So what they do is they come in here and they're like, all right, so this is going to be the square root of 15 times I. And that's about as far as we can go, because when I break it up, 1 over 4 doesn't reduce. There's no number in front of the radical to reduce. So you just include this I in the expression. And this is what's referred to as a complex number. Complex number means you got normal numbers and you got imaginaries. Something for the SAT that's super important is if you square the left side, you get negative 1. If you square the right side, you get I squared. And as far as the SAT is concerned, you need to know this more than you need to know the top part. But not so much for today's lesson. Let's keep rolling. Next example. One more time. I think something weird happens on this one. So A is 3, B is negative 1, C is 8. Start plugging along. Opposite of B, plus or minus square root of B squared minus 4 times A times C. Crap, that's going to be a big number. All divided by 2 times A, which would be 6. And that's 1 plus or minus radical 1 take away. What's that? 12 times 8 is 96. All over 6. Clean that up. We get 1 plus or minus the square root of negative 95 all over 6. They're like, oh, we know how to fix that. All you got to do is that negative just becomes an I. You stick the radical 95 back in front. 1 plus or minus over 6. Now, the only thing I got to ask myself is, can I simp this? Can I simplify square root of 95? Well, 95, the only number I can think that goes in there is 5. And that goes in there 19 times. And these are primes, so that didn't really help me. So I know it's already simplified. So bam, we're good to go. Sometimes, well, I'll just cover that in the homework if it comes up. Don't want to make these notes longer than they have to be. All right, application problem. Forest fires in California, big problem. This July, I kind of did a little research on this because I wanted the example to be like real. It said that the Cal Firehawk is a helicopter worth $24 million. California bought 12 of them. $288 million they spent. So let's assume the copter's flying over a fire, releases water as it flies over. So picture this. I'm not the greatest artist. I need my boy Dalton to draw this, but so I got a big old fire. I got a helicopter. It's pretty sweet looking, actually. And I'm flying at a pretty fast rate of speed this direction. All right, I'm a certain altitude off the ground. All right, this will be my altitude. I'm a certain horizontal distance from the fire. Now what's going to happen is, as I'm flying, I'm going to release the bucket. I think they said this thing could hold 1,000 gallons of water. And the water is going to follow a path like this. And what that's going to do, it's going to follow a quadratic, a parabola. And they give us an equation up here to model. So let's get rid of the picture. Let's kind of get after it. So it says the height y in feet of the water, t seconds, is modeled by that equation. So if you're a physics person, you understand that this is gravity, this is the initial height, and this is the initial velocity. Then they give me an equation for horizontal distance. I don't need that yet, though. Says at what horizontal distance from the fire should we start releasing the water? So how early, as you're flying into it, should you like pull the trap door to release the water? So step one, how long does it take the water to hit the ground? So basically they're saying, hey, find t when h is 0, because that's when it hits the ground. So I'm going to solve this equation. I'm going to say, all right, 0 is the height, negative 16t squared minus 2t plus 400. And I got to find the zeros here. Now, first thing I could do, because I want to shrink these numbers, because I know I got to do the quadratic formula. It's going to be kind of big. So I see all these are divisible by 2. So my first move is going to be divide both sides by 2, just to kind of shrink the numbers for myself. So I got negative 8t squared, take away t, plus 2 bills. So now I got my a, I got my b, and I got my c. So now let's get after it. So we got negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right. I got a big old number here I got to deal with. So what we got? We got 800 times negative 8, so that's 8 and 8. That's 6,400 positive. 1 plus, because these two negatives can be positive. So 1 plus 6,400, all divided by a negative 16. And I'm not going to simplify the radical because I don't really care about an exact value. I want like something meaningful in the real world. Kind of hate exact values. So I got to punch this crap into my calculator. So I'm going to punch in, there's two options. There's 1 plus, and let's see what the square root of 6,400 is. 64, oh shit, that's 6,401. So 1 plus the square root of 6,401 is, so this top part, when I do the plus part, that's roughly 81.006-ish, something like that. And I got to divide it by 2. So chop that in half. Oh no, not divide by 2. Divided by negative 16. And really, I just wasted my time, and I'll tell you why in a second. Divided by negative 16. Well, I wasted my time because it gave me negative 5.06 seconds. And that's not, like, we're not going back in time traveling somehow. I should have known that when I did the addition one, I'm going to have a positive on top and a negative on bottom. So I should have just skipped that. And I should have just did the minus version. All right, so let's do that. So come back, 1, take away, radical, 6,401, enter, divided by negative 16, enter. So that one, the positive one, was 4.93 seconds, 4.937. So maybe we'll just be lazy and round it to 4.9. Sounds good. So the helicopter dude or lady should basically pull the plug 4.9 seconds before they get over the fire, and that way it'll splash on it. So that's part 1. Part 2 is find the horizontal distance that the water is going to travel, and that's where we use this equation up here that they give me. And I have this horizontal equation that said the horizontal distance is 91 times the number of seconds. So I got to go 91 times that number I just found. 91 times 4.9, 445.9 horizontal feet. So in my original drawing, which I'm not going to redo again, if the fire's here, I need to be 445.9 feet away from the fire when I pull the plug. it's at a starting point of 400 feet. And I know that it's going to take 4.9 seconds to do that. All right, hopefully these notes helped you out. If you have any questions, ask me in class. See you. I said see you.